There is something majestic about a steam train going over a large viaduct surrounded by stunning hills and countryside. But while this may be the normal, stereotypical view, viaducts can be many shapes, sizes, and even made from material many wouldn't even expect. Also, having a railway running along a coastline had many advantages than moving it inland. For coastal towns, a railway was a lifeline for freight imports and exports, and with many railways well established by the late 1850s, tourism was also becoming a growing trend. The towns on the Welsh coast between Aberystwyth and Pwllheli wanted to capitalise on this. In 1862, investors and contractors David Davies and Thomas Savin had just completed the new Taunton-Machynlleth Railway. The railway connected to Chester and Shrewsbury respectively, and there was talk of a connection to the coast. Davies was all for this development, whereas Savin thought the idea too ambitious. Subsequently, the partnership could not last, and the pair parted ways to work separately on their own plans. In 1861, the two contractors submitted separate plans to Parliament. Davies' plan involved connecting Newton to Aberystwyth and Townend, whereas Savin favoured a different plan prepared by two existing railways that would connect to Aberystwyth and Pwllheli with several branch lines that would connect inland. Due to a technical error, Davies' plan failed to submit its documentation and as such lost its chance to be considered. So with no opposition, Savin's plan was approved and the Aberystwyth and Welsh Coast Railway was born. One of the many obstacles the railway had to overcome was the Maddock Estuary. This estuary was a major and important link connecting several mining towns to the coast, allowing them to export goods easily. Although the proposed bridge would connect both sides of the estuary easier, the bridge must not interfere with the export and import of these goods. Yet considering the size and the environment, the bridge must be very strong and hard-wearing. The development of the new bridge fell to civil engineers Benjamin Piercy and Henry Conyburn. The span of the bridge was over 800 metres, not the biggest by any means, but a decent size. And the architects knew that cost was at a premium. So rather than use stone or iron, the architects decided that timber imported from the Baltics would be the perfect material. It might seem an odd building choice, but wood was very popular, especially along the coast. The use of hardwood timber had many benefits. It was easy to work with, it was lighter than using stone, ideal for the estuary's riverbed, it wouldn't corrode in the sea air like iron, and it was durable. The only real threat was a marine organism called a borer. Borers, in particular shipworm, are mollusks or crustaceans that make their homes by digging into submerged timber. As many living groups, they leave a honeycomb shape in the timber wall, weakening the timber and in turn the structure. They embed themselves quite deep into the wood, often found at the wood's core. They're a real problem with them breeding by the million. They can eat submerged structures within weeks. Henry incorrectly concluded that these animals were not present in this part of the sea, and that a wooden bridge was the way forward, with a wooden drawbridge to allow for the tall ships to pass through. Construction began in 1864, with Thomas Savin as the overseer, but work was slow, mainly due to the tides and the difficulty setting the foundation into the estuary bedrock. Eventually, thanks to a bout of settled weather, the piers were sunk and set with concrete and ready to hold the wooden bridge by the June. At the northern end, a wooden drawbridge was installed. Wrought iron was used to support the drawbridge, and the bridge tilted back and rolled over using steel rollers, allowing for a 36-foot gap. However, once the railway was opened, towns would elect using the railway over shipping. In 1867, the bridge was declared open to the railway and to more unusually foot traffic. As the bridge was the quickest way over the estuary for miles, a walkway was also installed. However, in 1899, the bridge had to close for 3 years due to the iron corrosion and general works. One factor that needed attention was the drawbridge. The design was simply too complicated, so a swing bridge was installed instead. After surviving 2 world wars unscathed, the bridge became a lifeline for tourism. The fact that this bridge had a walkway as well was a real draw, and the views were breathtaking. Unfortunately, Henry's incorrect view on the marine ecosystem was beginning to bite. In 1980, marine woodworm had moved in on the old timber, and the results were damning. The railway halted all large locomotives and imposed a weight restriction, and a repair was done, taking nearly a year to complete. However, the weight restriction remained until 2005. In 2020, the bridge was in trouble again, and Network Rail decided a much more extensive repair was needed. They closed the bridge, and in a £30 million repair, the Grade 2 listed structure underwent its biggest restoration to date. They replaced the walkway, repaired damaged timbers like for like, and replaced the worn track bed. The only mechanism they didn't repair was the swing bridge, as this was now no longer required. The bridge is now as important to ferrying tourists as it was to freight, and is a lovely walk across. It will still unfortunately be open to the elements and face marine vandalism. However, the work Network Rail have done will mean that the bridge can be enjoyed for many holidays yet.